Hey guys, welcome back to the shop. Well, I'm sitting here Friday afternoon, just a few days before Christmas, and I've been thinking about something been on my mind for a while. So I'm a glutton for punishment. So let me show you what we're going to start working on. I think I have a game plan for trying to figure out what the heck's wrong with this thing. So let's show you what I'm talking about here. It's our old friend right here, old troublemaker itself. The Precision B&K Precision 1460. I'm going to revisit this bad boy, and I got a couple of things in mind. I hadn't decided yet what I'm going to do, how I'm going to do it, but some reason or other I cannot get the horizontal or the sweep drive to work. So basically it's kind of a loop how the system works. It's a feedback loop that you use. It uses a feedback loop kind of with the capacitors and the it's like an RC time constant in the sweep section. So when you turn this guy right here, it switches in different value resistors and capacity. But it's still a loop circuit. It's a feedback type circuit. So what I'm going to do is it's kind of a procedure that you use on a lot of circuits, like some of the old TV circuits. I remember years and years ago you used a feedback loop, like the RCAs and stuff. One of the things that you had to do was split that loop, then take like a 6-volt transformer or something like it and inject a signal into it, and follow that signal through the path to see where it was faltering. So that's what I'm going to do on this. I'm going to open the feedback loop up. I'm going to put a signal in there, and I'm going to see where the buck stops, and that right there will tell me, at least that's what I got in theory, what I'm going to do with this thing. So really all I'm going to do to it today, but I got it out of the shop there to get it out of my storage building to acclimate it. That's my storage building over there. You know, it ain't really humidity controlled or anything like that, so let it acclimate here, and then probably sometime tomorrow hopefully I can start on it. I'd really like to get that working. It was working fine till it quit working. So I got a lot against me on this one here. Not only what could I have done, the components that I've changed and the things that I've done to it, what could I have done to make this thing stop too. So not only am I trying to figure out what caused it to stop in the first place, I got to figure out what I might have done. So, but I'm going to do, at least that's my theory now. Like I said, I'm going to inject a signal into the front of it, watch it go all the way through, and watch it come back. See if I can find the problem. Anyway, just hang with me. We'll be back here in the next segment, see what's going on. All right, bye-bye. All right, so next day we're still working on this 1460, and yesterday I actually made a little progress, if you want to call it that. But this circuit right here, the sweep oscillator, basically is what this is, what they're calling it. It actually consists, sweep oscillators, this thing is kind of strange, but this is what you would think would be the loop right here, coming through, starting at Q10 all the way down through Q20, coming back around through Q14 and back up. I think whoever designed, yeah, here it is right here, through this right here, this circuit here, I think. Kind of odd. But anyway, I actually got this thing to do sweep yesterday. But this little capacitor right here, C9, excuse me, C9 is a 5 picofarad capacitor. It's a square wave here on this, what they call the square wave shaper. All right, it kind of controls Q10. It kind of takes the sync from Q10. I'm sorry, it takes kind of the sync from your incoming signal that you're trying to measure and converts it to a sync pulse to synchronize your sweep. And I actually got this thing to sweeping by changing the value of C9. I went from 5 picofarad to like a 0.001 microfarad, and it actually worked until you got it up into the higher ranges, anything around 10 kilohertz or above. Right here, you go, yeah, I think it was 10 kilohertz. You get above 10 kilohertz, it just stopped, and it started oscillating again once you took the input signal away. So that's telling me that this circuit is actually doing what it's supposed to be doing, but this circuit here is still not oscillating on its own. I think that's the biggest problem with this. It's not oscillating on its own. It's supposed to be a low-level oscillation that is synced by the square wave shaper right here through this capacitor right here. So there's still something in this circuit that's not working. I actually had a trace on it yesterday, a full width trace, that actually looked decent. But as you went higher in frequency, it finally just quit working to a certain point. And also, it would not work with anything on C9 here other than like a actually a 0.1 microfarad is what worked in here, and that's way too big. So this, I believe still we have an issue here with this circuit. Now Q10 is an FET, and which this is Q10. This is Q10 right here. It's supposed to be, according to this, a 3SK22G. If you can read that. Q10 3SK22G. Now that, let me get my notes. 3SK22G is supposed to be is an N-channel JFET. It has one grid, not two, according to this. The way I understand this, let's go back a minute, and matter of fact, let me pause here for a second and I'll show you what I'm thinking. Okay, let's look this up. 3SK22. Let's see if we can find it in the old RCA manual here. Well, it just says here a 3SK22 is a 3116, which is what's here. However, I guess what I'm trying to say, and I'm trying to remember now where I found it. There's a 3SK22G, and then there's a G2. There's different versions of it, but this is the hardest part number to find. But if it's just a G, that implies to me that it's a single gate. If you had a G2, that means it's two gates. So I'm going to go with that train of thought with this G right here. That's a single gate FET. And if you look at the schematic right here, you got your drain, you got your source, you got your substrate, and you got your gate. That's the only gate. Now this could be a G2 right here. I don't think it is, but because what they put on paper might not be exactly what they're supposed to be saying. Anyway, I approach this as a 3SK22 with a single grid. I guess this could be a grid too with a substrate, but I don't know. My knowledge on FETs in that order is kind of lacking. And there's some of this stuff you just can't find data on, and this is not 100% accurate. So anyway, I went with the idea, okay, it's a 3SK22G, which I found an N-type FET, and I did a test. Nothing wrong with that FET. Coming back over here, here's another one. That's another FET, but for some reason or other, one of the legs are cut off. Don't get me to lie. I can't tell you. Then I'm thinking this one right here. This is an N-type too, and I think this is the original. I can't remember. I don't know. I can't hardly read the writing on it, but I think that's the original FET right there. And it checked the same way. It had the 4th pin substrate. So anyway, I digress. This FET right here in this circuit right there worked exactly the same as this one right here. There was no difference in how these two worked in this circuit. But what I'm thinking about doing is taking this transistor right here, which I believe is the original, and I'm going to try to solder. Of course, I'm going to try to solder the leads back on here, get them really long, that way I can solder it and not affect it. However, these are very sensitive little devices, ESD sensitive little devices, very sensitive. And I may do that to put it back in here. But one of the other issues that I'm having with this, right now it's not operational. I'd show you how this thing, what it's doing. But the problem that I'm having with this right here is this 6 volts right here. This 6 volt level right here is low. Best I could tell, that 6 volt right there has got an arrow going here and an arrow going there. That's what it looks to me like. But that 6 volts is down about 3 volts, which means there's something not right here. This 4.8 volts is about 3.5 volts. So this Q11 right here is this transistor right here. This is Q11 right here. And that Q11 is supposed to be a 2SC371. And I've checked this transistor multiple times on the curve tracer and on my little transistor tester, and it works. It's nothing wrong with it. So I've pulled this circuit apart looking at the voltage divider network right here. R29 is a 10K. And then you have R32 feeding the base at Q12 through a 33K resistor. C11, which is a 100 picofarad capacitor, comes down here to Q11, and Q11 to ground is a 100K resistor. And then the emitter resistor is a 2.7K resistor. This R30 checks good, R80 checks good, R29 checks good, R32 checks good, C11 checks good. Q10, as far as I can tell, is okay. Q11 checks okay. I have not pulled 12 and 13 yet, but I'm going to. I'm going to pull these two once again and check those, and I'm going to check this diode D1 again closely. Maybe it's leaky, I don't know. But this thing is, but I did have it working, and I did have it sweeping, and it did work somewhat normal. And unfortunately, as I said a few minutes ago, as you increase your sweep speed, you can take your sweep speed and increase it all the way up, and it was a sweep. But once you put a signal into this thing of anything above 10 kilohertz, it will stop working. So it tells me there's still a problem in this A-stable. This is supposed to be in the A-stable oscillator. And it's not very stable. It's multi-stable. This thing is really strange. But the one thing I also am going to check, I'm going to go back to this Q14 right here and check that, because that is a feedback right there. And I'm going to check that. I'm going to check this diode, check this pot. And I'm going to check a few other things here. I'm probably going to go all the way back this whole loop right here. I'm going to check Q20, 19, 18, 17. There's another FET. I don't think that FET's got a problem, but we'll check it. I'm going to check D1, Q12, Q13. Something in there is not right. And also, I think I've already checked D2, D3, and 4, but I may substitute those for some modern resist diodes, probably some 1N, I want to say 1N914, but I'm not 100% sure on that. My little switching diodes. Let's see, my memory ain't too good. Oh, I'm sorry, 1N4148 switching diodes. I'm going to put some little more modern diodes in there and see what happens. Because those that's in there are some old pill, I call them pills. They're little green and black round diodes that I've never trusted. So anyway, that's where I'm at on this right now. It is sweeping. It does work. Just not like it's supposed to. So that's actually more further along than I have gotten. But I had to increase the size of that capacitor right there to make this work. So that's my next step. I'm going to go ahead and put these two components back in there and just start pulling the other components out one by one. 12, 13, 17, 18, 19, 20. I'm going to check all of those components first, and then I'll go from there. So anyway, that's where I'm at this point. Alright, I got the Q10 in there back replaced, back together. I have Q10 put back in and Q11 put back in, and I put all the resistor networks back in. I got the CRT back in it, so let's see if it still works. Oh, and I did not put the big capacitor in there. I need to do that. Let me put the capacitor in there and I'll be right back. Alright, sorry about that. I went ahead and put that 0.1 in there. Let's try it again. Unless I've damaged something, this thing should give me some sweep. And there you are. Sweep. As you can see, it's there, you just can't see it. Let's see here. It's got a kind of an oddball right there, but I think that's just, not really sure what that is. It ain't quite right, but as you can see, it is sweeping. It does work. It just not worked right, but you have to have this capacitor really high value to work. So with that being said, with all that being said, I'm going to go ahead. I know that transistor is good. I know this transistor is good. I'm going to go ahead and start checking components one at a time through this whole chain right here and see if I've got something else going on. So that's where I'm at with this right now. So I will report back when there's something to report. Alright, here's Q12 right here. It's calling it a binary junction transistor NPN. The beta is 77 and the voltage forward is 726 millivolts. That's about normal for these little transistors. You don't have a whole lot of gain. Let's do it again. So that was Q12. That's Q12, which is this one. So that transistor checks good, but I'm going to check it with a ohmmeter just to make sure that it ain't got no funny business. And we'll put it back in, and then I'll come down here to Q13 and we'll check it next and do the same thing. And while I have Q12 out, I may go ahead and just pull 13 as well. And then I'm going to check this R34 10K right here, just to make sure I don't have something going on there. And I guess while I have these two out, I'm going to go ahead and check R1 and D1 while I'm at it. So that's what I'm going to do next. Alright, here is Q10, 11, Q13. Still connected. It checks as a BJT. NPN. He's got a beta of 85 on this one. And the V forward is 726 millivolts. So, again, that's Q13, I believe. And, which is this guy right here. So it checks good. I mean, it checks good. So I haven't checked them with an ohmmeter yet, but I'm going to put it over here, and then I'll go back and check it with the ohmmeter. And then I'm going to, while I have the ohmmeter out, I'm going to make some static checks here on the R35 and R34 here. I already checked that. So I'm going to check the resistances of this circuit right here, and then I'm going to check these semis right here, and just continue going around. So that's where I'm at. Alright, got you on a tripod. Would y'all believe that? Anyway, I got you looking at my my Fluke multimeter here. And I'm going to check this Q13. It's a 2SC, I believe, 371. What it says, at least. Checks good, you remember. It's had a beta of 82, I think. So we'll go from base to collector. Reading 0.949. If we go base to emitter, you'll notice it's going to be lower. Let's see, at least I thought it was. Yeah, the collector's always going to read a little bit lower than the emitter. That's how you can tell where the collector is. See, that's 0.975 and that's 0.948. So that's actually good. So I'm going to reverse my leads. And alright, I'm putting my, it's an NPN transistor, which means the base, when you want to measure the forward bias, the base would be positive in respect to the collector and emitter. So now I've turned it around. Now my base is negative. I'm checking from base to collector through transistor, and now I'm going base to emitter. See, and then I'm going to go measure from the collector to emitter, and then collector to emitter the other way. So that transistor checks good. And right, we're going to go back to Q12 and check it now. I'm going to do the same thing. I'm going to go positive on the base. And then we'll check collector. That's about 0.988, 987. That's on the collector. This base to emitter checks kind of high though. As you see that measuring really high. That's kind of odd. Let's do a reverse on this thing. Even though it does work, it does checks the kind of, see how that collector is 0.987, and I'm checking the base to emitter junction. It's reading right at 1 volt actually. So this one's kind of odd. What are you? That transistor's kind of odd. Q12's kind of odd. Imagine that. I'm going to write on my little notes here, high B to E resistance. That's the other thing I'm doing, is I'm comparing the readings between one transistor and the other. I want them all to kind of measure the same. But let me continue on with checking these transistors and I'm gonna get a better view of what's going on with these things. Whoop. And what I've done is I'm just writing down Q12, Q13. I'm gonna move this. These things ain't be unstable, and write down what I might be finding with them. So anyway, I'm going to do that. That's Q12, Q13. I'm going to do that with the rest of these in this path right here, and get a consensus, and then we'll see if we got enough components to replace the ones that's acting funny. Alright, got you guys in here. I've still working. I'm in this circuit right here now, R35 and D1. Measured 0.820 ohms, and I measured it both ways. Kind of low reading, actually. Don't know if that makes any difference or not, if there's something interfering with that reading. I don't know. But I went ahead and unsoldered D1, and I've unsoldered one side of R35. And here's D1 right there, that little green and black sucker right there. Remember, the black is on the right. That is old school semiconductor right there. Old school. I don't trust them, to be honest with you. Alright, got that out. It's called D1. So I'm going to probably have to put you guys down for a minute. I don't want to put you on a tripod for this, but now that that diode's out of there and that collector of that transistor Q13 is out of there, I should be able to get a decent ohmmeter reading. That R35, even though the schematic says that it's a 1000 ohm resistor, and I measured about 820. 820 is kind of an exact number, right? Where's my pointer? But I don't know if you can see that or not, but look at that red mark right there, and that looks like a brown to me. Now the gray's missing off of this, but that thing has been washed and everything else. I'm thinking that's an 820 ohm resistor. I think it's fine. So I'm going to test this diode here, D1, and see how it does. Since it calls itself a Zener diode, I'm actually going to check the front to back on it. I'm going to see if it's actually, make sure that it's not leaking, and make sure that it actually is a Zener diode. So that's what I'm going to do next. But I think that's an 820 ohm resistor right there. It just, I can't see the gray on it. Get it out. I'm out. Yeah, that's a gray. You barely see it right there. Where you at? There's a gray. That's an 820 ohm resistor. So the schematic is wrong again. That's the trouble with this old stuff. This one here is apparently this version board. You know, it took me forever to get the right schematic for this thing. I had to email B&K themselves, and they dug up some schematic out of somewhere, and kind of a crappy copy, but this is the only schematic I could find that matched that board. And of course, there's a component that's not the same. Anyway, I'm going to check D1, a little Zener diode, and I don't know what its rating is. I got to go look at the schematic on that. So let me do all that, and I'll bring you back. Alright, it took me a minute to get set up, but I looked up that Zener diode that I pulled out of there. It's a little black and green sucker right there, which is this D1 right here. And this turns out to be a very old part number. And let's see, it's D1, it was a ZB1-6. Or is that a DBI? I call it a DB1. Anyway, I looked it up, and it's kind of easy to figure out. But it's a 6 volt Zener diode at 1 watt. So what I've done is I put on my test setup right here. Got my variable bench power supply right here. Going through a 47K dropping resistor. So I've got my voltmeter here between the negative side, or the cathode side, anode side for the negative, and then the positive side of my meter is tied on the load side of the 47K going to the cathode. I always reverse bias on these Zener diodes. So anyway, here we go. We're going to test it. Basically, I'm just running voltage through a drop-in resistor to see if this thing actually clamps. Okay, I'm at a volt. Getting up to a lot of glare. There you go. I'm at 2 volts. I want to see if this thing actually acts like a Zener diode. I'm at 3 volts. Getting up to 4. There we are. I got about 4.5. Getting up here to about 5. We're getting close. Here's 6 volts. As you can see, I'm up to about 12 volts on the volt power supply, and it's holding steady at 6 volts. So it's acting like a Zener diode should act. So I'm going to check the front to back of this thing just to make sure it checks good, and I'm going to call that diode good. Alright, this D1 ZD1-6 6 volt 1 watt Zener diode checks okay. So Q12 checked a little funny. This is kind of summarizing. It checked the base to emitter junction, read kind of high. It read about 1,000 or 1 volt on my diode function of my meter. It measured about 1 volt. And remember, this one right here measured 0.947. So that one's questionable. Checks okay, but it's still questionable. So we'll come back to that. And so I got to do Q14 now, which is this one here, and that's in the feedback loop. And I'm going to do these 4 transistors too, but now I think with that text message you guys just heard, I got to probably stop for a while. So I'll bring you back when I get back on all this stuff. Alright, I finally have all the pertinent transistors for the sweep section right here, or the semiconductors, I guess you could say. Starting at Q12, it checks good on my little transistor tester. This thing is a little Chinese thing. You know, you've seen them, thousands of them on the market. This thing is really handy to have. Really handy. I know it's, well, I think $20. I bought it like 8 years ago or something like that. Works great for identifying transistors. Anyway, it checked good on that. I mean, it identified it and it told me what it was and all this kind of stuff. However, if you remember, the base to emitter resistance reading, or actually I call it resistance reading, I guess you can call it that, but the on this meter here, it's got K ohms in the what you call the diode mode. In the diode mode is basically telling you the or the voltage drop on that junction. Anyway, the voltage drop on this base to emitter junction was relatively like 1 volt. All the rest of these is like 0.928, between 0.92 and about 0.97 on the base to emitters on these things. So this one checks different in that regard than the diode check function of the volt on milliamp meter, or the digital voltmeter, and as compared to all these other ones. Now this is a junction transistor right here, Q13, Q14, Q17 is the JFET, it checks okay, Q18, Q19, and Q20, and then this D1, that 6 volt Zener diode we checked just previous segment. So right now, those transistors and everything that you see on this piece of paper here started from here, here. This is Q11. This one right here is Q11. Q11 checked okay. It's in the circuit. Q10 and 11 are still in the circuit. So Q12, which is this transistor here that checked odd as compared to the rest. This is Q12. Q13 right here. D1, which is that Zener diode right there. I haven't got to these guys yet. Let's see. Coming over Q17, Q18, Q19, Q20, and Q14. All checked good. That's all of these guys. That is everything in that sweep circuit. So, assuming, let's just assume for a minute that I'll replace Q12, which I'm going to do. I've got a pile of those transistors somewhere that I just have to search through them and find the one that I'm looking for. One that has betas. The betas on these things check anywhere from like 62 to 88. I'm not too worried about the beta on them. I would prefer all the beta to be the same. However, that's just not possible. Unless I buy $1,000 worth of those transistors and keep going through them. So anyway, getting back off track already. This 1K right here was actually an 820. That is so far one of the few times I found a difference in the schematic. So that's an 820. So all these resistors and capacitors in this component in this section right here checks okay. So next thing I'm going to do is I'm going to come back up here and I'm going to start checking. I'm going to recheck this. I'm going to recheck this circuit. There's something wrong in the circuit. I don't know if Q12 is responsible. I think a transistor is probably not the best in the world, but I think it should work enough. But anyway, I'm going to check D3, D4, D2. I want to try to identify them and see what exactly they do, and I may just replace them with some switching diodes that I have. And I'm going to try to double check this a little bit more, and I'm going to check a few more static chest some components in here. It's going to take a little while, but something's not right. Then you get down in all this back in this old crap here with your auto, your slope plus and minus, trigger levels, internal, external line, and all this kind of mess, TV, horizontal, vertical switches, all that crap. It goes between here, here, and here. All kinds of manner of things could be wrong with this. It could be in this section here. This is your sweep speed right here, sweep time. It could be in this. But a lot there. But I'm going to find a replacement for this one. I'm going to put all these transistors back in. But first thing I'm going to do is just make some spot checks on some of these resistances and stuff. And I'll also check these components here, these 3 diodes. I'll get to those there and check those to see what they are and what they might cross out to. And I may just put some switching diodes in there. It depends. Some of this stuff, like D1 and D3 and 4 here, sometimes they have special characteristics that you can't just throw anything in there, because this does affect this FET right here. I wish they give waveforms and a little bit more detailed ways to troubleshoot this. So anyway, I'm just kind of getting my mind started on this right here. It's early Tuesday morning, day after Christmas. Trying to get my mind working. But what I might do is come right here, inject a signal, pull D2 loose, inject a signal here, and get my oscilloscope and come right here. I don't know. I guess what I could do is go from 11 right here and 10 right there, and with this Q17 pulled out, and inject a signal in here, put a scope on here, and just go through this range and just see. I don't know if that would prove anything. I don't know what it would be on this range switch if that was a problem, because it affects all ranges. So I'll probably just yapping at the wind here. But I'm definitely going to check D2, 3, and 4. So let me get on with all that mess right there and do some resistance checks of all these things and make sure that I don't have a bad resistor. Entirely possible. It's going to take a lot of time to do that, but excuse me, I think it's worth it. Because if it's not transistors causing the problem, and it's not semiconductor diodes causing the problem, then it's got to be resistors or caps. That's all that's in the circuit. That's all it's made of. Resistors, caps, semiconductors. So anyway, that's where I'm at. So back in a minute. Alright, I have all the resistors, and I'm sorry, all the transistors back in place, and the D1 6-volt Zener diode. The only thing I've yet to put in is Q12, which is that transistor that didn't check quite right. And I have two of the 2SC 371s. I'm sorry, 2SC 371s, yes. Had two left. Anyway, this is one of the two here. I checked it. It checks good. The beta was about 82. The front to backs looked good. The from the base to collector was like 928, and the base to emitter was like 968. So that's how these should check. The collector always reads lower than the emitter on these transistors as far as resistance readings. So that goes in next. I've checked. I kind of did a spot check of all the resistors in here. Pretty much every one of them checked okay. There were some that checked quite kind of funny. However, they were lower in value than higher, which is not how these things die. They usually go higher, which means there's probably some other stuff interacting with it. And I honestly didn't feel like pulling it out to check. So I'm about to put this transistor in, clean up everything, make sure I got everything right. I'm going to power it back up and see what happens. Oh, and a little, in case y'all ever decide to work on one of these relics, let me get this light in here. But a little information. Let me get in here. Here is one of the, here's Q12. Where am I at here? Oop, super glare. Hang on. Let me get the glare out of the eye. I'm going to zoom you in a little bit. Q12 right here. This is the one I'm fixing to change. But you see that little symbol right here. What this symbol means, right here, the long line, there's a dot and nothing. And a no line, just kind of a line connecting to the circle. Anyway, what this means is, this long line right here represents the base. That long line right there represents the base. The line that looks like the minute hand or something in a clock goes all the way to the center right here. That depicts the base. This one here with the dot, that's the collector. And then this one here, of course, is the emitter. So this is B, C, E. That's how you know to tell how to put the transistor back in. So, looking at the transistor, the base of the transistor, if you're looking at it, where are you at there, transistor? Got you zoomed in so much. Oh, let's unzoom me here. Let's get this where you can see it. Just FYI, this is the flat spot of the transistor facing up, and the leads are facing away from you. So what we got here is base, collector, emitter, BCE. If you put your voltmeter on diode mode, measure from here to here, you're going to get a low, if it's working right, from the base to the collector, you're going to get in the 900 and something on this particular type transistors. You're going to get somewhere around 930 ohms, plus or minus, probably, I don't know, 50, 60 ohms, something like that. But the resistance between here and here will be lower than from the base to emitter. In other words, you could say it a different way. The emitter is going to read higher than the collector to base. So anyway, little FYI. Alright. Believe I have everything back in like it should. Sans this funny chicken transistor right here. I've been down this road many times with this thing. I pulled the capacitor out. Oh, hang on. Let me get my schematic. Apologize for that shaky cam for the minute there. But I went ahead and pulled, where's it at? C9, that 0.01 or that 0.1 I think it was, that I had across to C9, which is about a picofarad. So Q12 has been replaced. Every other transistor in here, this whole circuit, checked good. It should work. I don't know why it won't. Every transistor has been checked good, is put back in properly. But here we go. I don't know what else to do. Power up. May go poo for all I know. Let's turn this light off. We don't need that light. Will it work? Look at there. There is a trace. I kid you not. Look at that, y'all. It is working on its freaking own. Amazing. Look at there. Look at that. I'm up to 100K. I'm up to 1 meg. I don't know what this distortion is, but I'll figure that out in a minute. That is amazing, y'all. That could be magnetic, because I don't have the Aquadag shield on there. Look at that, y'all. It is freaking working. It was working. It's amazing. Doesn't seem to be stable though at that higher frequency. Let's go up. Well, it's a lot better than it was. It's still right there in that kind of oddball zone. Let's find the gain. Make sure I got this right. That odd little distortion right there. That's kind of weird. This slope. Let's check the slope here. Let's go to square wave. Check the slope. Slope seems to work. Horizontal sync. Oh, I'm sorry, that's just source triggering. I'm sorry about that. Once it stops, though, you have to manually start it. It's still right, but it's, I think Yeah, this slope thing here, that's weird. I don't know if that's magnetism. Whatever, get out of my way. Dead on that one, that function there. So it's working on its own now, but it's kind of the magnification. I think that's a switch. Yeah, the magnification switch is kind of. Yeah, that little bump right there, I'm not sure about that. It's not super stable, but it's at least working on its own. That is different than what we've seen so far. So that's interesting. So let me play with this a little bit and see what's going on. So hey, we've made progress. I'm fiddling around with some of these adjustments on here. Just, you know, the thing's out of calibration anyway, so what the hell, you know. But just messing around with some of the adjustments on here. Now let's step through the sweep ranges. So far, I have not lost my sweep on all the sweep ranges. Going from the bottom, half a second sweep all the way up. That's 0.5. Let's see if we can make it go that high. I don't know. Can or not. Yep, there it is. It's never done that. That is, I have not seen it do that in months. So I think at this point I'm going to turn it off. I'm going to put the put the shield back on. Put it all back together like it should be as far as that goes. And I'm going to turn it up right so I can get a better view of it. Let's just let it run a little while. But wow, what a progress. Before I pulled the CRT out of it right here. Let's see, it's a Toshiba, I believe. I think it is. We'll call it Toshiba. A 130 ARB1. Actually pretty decent. But this is apparently a barn find. You can tell by it's been weathered. It's been out. It's been really bad. But you can see the B&K label here is faded. All this stuff should be a real bright golden. All that's all faded. Anyway, you remember the earlier pictures of this thing, what it looked like. It's pretty rough. One of the things was this filter right here, this oil field capacitor, had a hole in the bottom of it. And PCBs or not, I'm not 100% sure, but you know, got to die something. Anyway, I cleaned it all off and resoldered it, and it seems to be holding, so I don't have to replace that right now. But anyway, I wanted to show you that before I put it back together and turn it over. Alright, I started to doing adjustments on this thing, and I noticed as I was playing around with it that I lost my sweep again. Right now you see that I have it back, but started playing around with the controls again and nothing made a difference except for the width control, VR5. Watch this, I'm going to turn it. See, it just stops. Boom. Nothing. And I'm turning it, it's like it messes with it a little bit and then it stops. It's like all of a sudden always in the same place. I'm wondering if this pot is bad. I mean, it's entirely possible. So I'm going to pull the control. I'm going to pull that pot and check it. But let's just play with it. Let's just see if we can get it working again. There's the width. Alright. Got the width going. Let's check the different sweep rates. I mean, this, you can see that it's working. So let's keep it right there. Let's go to horizontal position. Let's get it right in the middle. Now you see it like right there. That's what it needs. So it needs to come up. So let's see if I can get that right. The position, that I don't know what that is. That doesn't seem to be working too well. But let's do mag center. Mag center may have a little bit of retrace in it. Let's see. Stability, mag center. What am I forgetting here? Position 2. Here's position 2. Vertical seems to be okay. Let's try the time base again. Time base going all the way up. All the way down. So let's go back to the width. I guess that's what that is. It's WID. I don't know what else it'd be. But I'm playing. Let's see it stop. Boom. Boom. It gets to one little plateau there and dies. I'm wondering. I sprayed this control already with my electronic cleaner. But let's pull that control. Let's power this down. Get my desoldering iron. Let's pull that control and let's see if it's bad. It could be because it was right on that board. Let's see, which one was it? This one right here. If you can see it well. It was right there on that board, and that's right there where all the corrosion was. So if it's good, I'll be surprised. So let me pull it out. Alright, I started to doing adjustments on this thing, and I noticed as I was playing around with it that I lost my sweep again. Right now you see that I have it back, but started playing around with the controls again and nothing made a difference except for the width control, VR5. Watch this, I'm going to turn it. See, it just stops. Boom. Nothing. And I'm turning it, it's like it messes with it a little bit and then it stops. It's like all of a sudden always in the same place. I'm wondering if this pot is bad. I mean, it's entirely possible. So I'm going to pull the control. I'm going to pull that pot and check it. But let's just play with it. Let's just see if we can get it working again. There's the width. Alright. Got the width going. Let's check the different sweep rates. I mean, this, you can see that it's working. So let's keep it right there. Let's go to horizontal position. Let's get it right in the middle. Now you see it like right there. That's what it needs. So it needs to come up. So let's see if I can get that right. The position, that I don't know what that is. That doesn't seem to be working too well. But let's do mag center. Mag center. May have a little bit of retrace in it. Let's see. Stability, mag center. What am I forgetting here? Position 2. Here's position 2. Vertical seems to be okay. Let's try the time base again. Time base going all the way up, all the way down. So let's go back to the width. I guess that's what that is. It's WID. I don't know what else it'd be. But I'm playing. Let's see it stop. Boom. Boom. It gets to one little plateau there and dies. I'm wondering, I sprayed this control already with my electronic cleaner, but let's pull that control. Let's power this down, get my desoldering iron. Let's pull that control and let's see if it's bad. It could be, because it was right on that board. Let's see, which one was it? This one right here, if you can see it well. Right there on that board, and that's right there where all the corrosion was. So if it's good, I'll be surprised. So let me pull it out. Alright, kiddies, we are going to check R5, I believe. It's a 10K potentiometer, and look what we're checking it with. This triplet 630 NA that had the leakage on the wafer switches. Thing's working great now. Anyway, let's see if it's 10K. Well, it's reading about 9K. Okay, well, that's cool. Not quite what I expected, but okay. Let's see if it works. Let's see if I can make this work. Let's see if I can keep my meter leads on here long enough to even do something. See right there, there's a bad spot in it. Right there. See that right there? It's not super bad, but it ain't super good. Look at that. You see that? Well, half of that could be these stupid meter leads. These cheap ass Chinese damn little mini grabbers. It just, I don't know. I don't trust it. I'm going to put something in there I know will work. If I can find something. So, let me go find a 10K. Alright, I don't know how this is going to work. The pot was not 100% clean as far as its function. So, the only thing that I had in my stock was a 10 turn pot right here. Potentiometer. So I'll put that in there right now, just to see. I figured all along with this thing that I would have some problems with some of these variable resistors on that board, and so let's see what happens. It'll either work or it won't. Says it's on. Alright, let's play with that pot. I don't know which way is to go. Oh, there's something. It likes that. I'm going to leave that there for now. So let's see if we can get it wide. Alright, we're getting there. Now, I'm going to calibrate the time base. I still think we have some sync issues. It's a lot cleaner. So let's get the light out of the way. This light, this bench light is a love-hate relationship. Let me move you guys over a little bit. Love this light because it makes me where I can see, but damn, it gets in my way. Everything I try to do. Alright, y'all can still see, which is something amazing. Let me see if I can find a longer BNC cable. I know I've got one around here somewhere. Somewhere I got a longer BNC cable. This BNC cable, a little different. Chinesium adapters that I've got. Oh Lord, hang on. Damn. Now that we got all that, I can pick this thing up a little bit and we can see. That's what we need to be able to see what the daylights we're doing. There. So let's go up in frequency. Okay, that's cool. So far, so good. Alright, so far so good. Stability control seems to be working. Look at there. Get a little jitter. It's really good though. How about that for an improvement? Looking at the trace seems to be level with the radical, so that's good. See illumination. Let's turn the illumination up. I really like this oscilloscope. It seems to be working really good. Let's do slope. Slope seems to work. That's a relatively bright trace on it. Play with the astigmatism a little bit. That's pretty sharp. So I'm just gonna let it run. I'm gonna just let it sit here and run. I'm gonna let it cook probably the rest of the day, just like it is. That's really good. I'm gonna let it run. I'm liking it. Alright, about an hour or two, several hours have passed since the last segment. I've made some progress, but this thing still is not out of the woods. The last time this I call it width. I don't know if it's, I don't think it's width. I'm not sure what this is. Yeah, I can't find it on the schematic. I can find it on the schematic, but it doesn't tell me what exactly it's supposed to do. So anyway, it doesn't really make any difference on how to operate it. I'm probably going to put the other one back and clean it up a little bit better. But one of the things that I've did, or done, or whatever, is going back to this good old 3SK22 right here. Q10. I did find the original that had the two legs broke off. I was actually able to solder two leads onto that in a very delicate operation. Took a big chance of blowing this thing. It's a very ESD prone. Well, one of the problems that I was having with this thing is still a feedback deal. I apologize, my head's full of snot all of a sudden. Basically a big feedback path right through here. But what was happening was this this control right here, this blue one, is right, let me find it, VR5 right there. The center of the VR5 comes to R56, comes down. There is a variable capacitor here. I've tried adjusting that. I hadn't seen it make any difference. It's got to make some kind of difference. I don't know what it does unless it's bad. But here's D5. Here's a 1 meg resistor right here. Comes over here and feeds the base of Q14. Now, here is different value capacitors. So as you change your time base selection, it changes different capacitors here. I'm thinking this looks like an RC network. It's a 1 meg resistor here and a bunch of capacitors here, all different values. I'm thinking that's an RC network for timing. Anyway, I'll get to this in a minute. But anyway, this voltage right here, this is 12 volts from the 12 volt rail. The emitter voltage comes down here in the stability control. This is ground. The other side of stability control comes back up to the circuit board to another stability adjust, which, you know, goes through this little network and goes back to the 12 volt rail. Anyway, that kind of puts a pre-bias on this thing. Anyway, the output of this and the stability of this comes through here, R26, 22K, 2.2K or 22K, I can't understand that. Comes up here into the gate of Q10. So, it says here the gate should have 3.5 volts on it. When this thing is actually oscillating and doing its thing, it's actually pretty close. However, when it fails to sweep, everything changes. This gate voltage right here will drum up to about 9 or 10 volts. Personally, I think that's a lot of voltage for that Q10. But let me back up a minute. When I replaced this with the original FET, it worked. It actually worked. It worked a little better actually, which I couldn't believe it. But I feel better now that I've got It works a little better, but it ain't quite out of the woods yet. Anyway, getting back to what I'm talking about here. I fiddled with the stability adjustments and this control here, this VR5, and I've got it where it actually works pretty decent. But one of the things I've noticed, and it's kind of odd, and I'm still playing with it, trying to get a pattern. But here's your time bases here. Your 0.5, your 5, your 20, your 50. Anything that's got a 5 on it doesn't work properly at all. It just seems to fall on its face. And it's more prevalent right here on this 50 milliseconds. I can't remember now if it's 50 or 5. I got to go back and look. But all the other ones seem to work. I'm just wondering, assuming that everything in here is good. I mean, my God, how many times can you check a transistor? Really? You know, I have to draw the line somewhere. It can't be the transistors. I'm just going to go out on a limb and say it can't be the transistors. We pulled every damn one of them things and wrote it down on this list. Which ones are good? Which ones are bad? Which ones, whatever. All these diodes check good. As many resistors as I could find and verify check good without having to pull them out of the circuit. So assuming the transistors are good, what could be causing this problem? The only thing that I can think of, and this is a BITCH, is something in here that's associated with each one of these 0.5s. There's something, maybe switch leakage, just like on this meter here, that if you remember that video. It could be some kind of leakage on here, upsetting the bias apple cart on this loop. It's actually a freaking loop. Everything comes back through this diode right here and this transistor. That's how this stupid thing works. It's a big loop. I guess I could pull this transistor here. This is supposed to be a free running oscillator, low level oscillator they call it. If I pull this loose, or pull this resistor right here, I guess, pull this capacitor, pull that resistor right there, this thing should oscillate all by itself. That's what I'm told. That's what I understand in reading the nomenclature on this, or the diagram, the theory of operation. So I don't know if I've got a problem in here or here. Well, it wouldn't be here, but here. There's a bunch of capacitors right here and a bunch of capacitors right here. What if we have one? What if we have a problem in one of those? What if some of these resistors are out of tolerance? What if some of these variable caps are not quite right? You know, I did have to change one of these capacitors, that right down there. I had to change it because it was totally eaten away by mice. Really no way to get to this. So I don't know. I really don't know which way to go with this. Could it be corrosion on the wafer switches? I don't know. I had to get away from it a little while. I'm trying to decide if I want to mess with this a little bit more today or not. But it is working on its own. Let's see if it still works. It's been off now for about an hour. Let's see what it does. Let me grab my coffee. I think I'm going to kill myself on coffee. Every time I turn this thing on, I hold my breath. But it's a cold start, if you will. Right now I've got it on the 50 millisecond per division, and look at there, it came up and worked. 50 microsecond. So let's see. Starting at the 50, let's go up in range. So 20 microseconds, 10 microseconds, 5 microseconds, 2 microseconds, 1 microsecond, 0.5 microseconds. Let's go back down. It should be 1 microsecond, 2 microseconds, 10 microseconds, 20 microseconds, 50 microseconds. Just for grins and wiggle, just turn it back off. Units off. Let it set a minute. And if I got to mention, or did, I may have forgot, but I think it was just now it's affecting the 5 milliseconds. I think the higher ranges are okay, but I'm not exact. I can't remember now. That was about an hour ago, and I've had a snack and I've had a short nap. But look, it comes back up on the 50 millisecond range. So that's actually good for this thing. So let's go down. Let's see. Actually, that's 50 milliseconds. Anyway, there's the 0.1 I'm sorry, 50 microseconds. I'm stupid. 0.1 milliseconds, 0.2 milliseconds, 0.5 milliseconds, 1 millisecond, 2 milliseconds, 5 milliseconds, 2 milliseconds, 5 milliseconds, 2 milliseconds, 5 milliseconds. Let's go down to 10 milliseconds, 10 milliseconds, 20 milliseconds. Go back up to 10, 5. I'm going to do the same thing we did a few minutes ago. Power it off, power down, and give it a second. Power it back on. Here we go. 1, 2, 3. See? That's new. I mean, since I've changed that to FET Q10 and tweaked it again, a few adjustments, I've actually gotten pretty. It's getting stable, more stable as I mess with it. Now we're down to 10 milliseconds, 20 milliseconds. This is where we're getting into land. Here we go. 50 milliseconds. Now the stupid thing gonna work. Make a liar out of me. Well, the thing that's changed, other than me changing the FET back to its original, is it's cool off.
Come in, Dave Miles. Go ahead.
There's 5 milliseconds, 10 milliseconds,
Well, we're gonna show it my
20 milliseconds, 50 milliseconds, 0.1 millisecond,
Treetop, cut out.
0.2 milliseconds.
Alright.
Alright, 0.5 milliseconds.
Yeah. You need to do a wire down on Cop Street. So everybody
Well,
knows that's like that.
I don't know what to say.
Alright, what's that address on Cotton? I'll let you over. 214 Cop Street.
I don't know what to say. I know what I saw. Which means we may have a thermal issue with this thing. It could be one of these transistors in here that's thermally, whoop, thought I saw it quit. Ah, there it goes. 50 milliseconds, 20, 50. .1, 50. There we go. 20. 20. That's 50 milliseconds. 0.1 millisecond. 0.5. Let's see. 0.2. 0.1. Okay, the 0.1 is not with us right now. 50 milliseconds. Well, maybe I just misremembered here, but okay, the 0.1 second function's not working. 50 milliseconds working, 20 milliseconds working, 10 milliseconds working, 5 milliseconds working, 2 milliseconds working, 1 millisecond working, 0.5 milliseconds working, the 0.2 milliseconds working, 0.1 is working, 50 milliseconds working, amazing. The 50 microseconds working. God almighty, dang, how many times can I screw up? Anyway, 20 microseconds, 10 microseconds, 5 microseconds, 2 microseconds, 1 microsecond, 0.5 microsecond. We seem to have a little issue with blinking right there. And that could be part of the problem. Who knows? This thing is so interconnected. Right now it's the 0.1. I mean, if the 50 will work and the 0.2 seconds will work, how come the 0.1 does not work? So maybe we just need to troubleshoot that for right now and let this thing warm up. Troubleshoot, figure out why that one's not working, and go from there. It could be a capacitor, could be a resistor. Who knows? This is one of the most perplexing piece of test equipment that you'll ever work on. So let's see. What we got? 0.1 second per division. So let's see. 0.1 second per division right there. We're connected there. Connected there. And we're connected there. And so this circuit here, the feedback loop I call it, is connected here. In other words, not there, but here. Comes down. And I believe that's grounded. This schematic has a lot to be desired. Wish I had a cleaner schematic. So it's a 0.22 microfarad. But that's common to all three of these right here. So I would think if there's a problem with this capacitor, that it would affect these three ranges. So I'm going to kind of discount that one. So let's go up here now. The next one, this right here. So D3 and D4 comes to input 11 right here. And then it switches through this port right here. And it comes down here. I'm looking here just a second. Yeah, it goes through this variable right here, VR105. So let me see, what is that? Yeah, that's actually the other end of this freaking resistor over here. This thing is flaky, it's weird. We're just going to say it comes through right here through this 1 meg through VR105 to ground. So that's pretty much a direct connection right through R125 right there. So okay, no problem. So we'll go up Let's go. The center of this right here, by the way, goes back over here to Q17. Amazing. Anyway, it goes up here, comes through C114, which all three of these lower bands are common. So the C114 is that one microfarad that I changed. That was the one that the mouse ate up. If you remember a long time ago when we first started this, that was the one I changed right there. Is it possible that maybe I have the wrong value in there? Perhaps, but we'll see. Anyway, jumps through there, goes through the C114, comes down, comes all the way down into this 1 meg. So the variable is this right here. Is this knob right here.
I can't see any of them orders. I don't know why. I tried to put them on my phone earlier, but I can't see any of them.
Now see, I turn the variable down.
Yeah, I do let you know good enough. Man, where can't they go? Yeah, man.
So with that variable there, let's just go down to the 0.2 second division. So there. And I've noticed that as I turn the variable down, that it will stop working. As you can see, it stopped scanning and sweeping right now. As far as I know. So it apparently has something to do you see our 50 has stopped again. See, I wasn't lying. $50 has died. So apparently as it gets warmer, interesting. Let me move my coffee out of the way. I don't have any freeze spray. That's what's aggravating. See that? Just cool that board down a little bit. Straightens right up. So there's something thermal in here. So what I'm going to have to do is pull the discussion off the front, pull the CRT out, pull the magnetic shield off, and use an oscilloscope as my screen to tell if it's sweeping or not. And I'm going to have to go in here and let it warm up, or use my new heat gun I've got. is see if I could find what is thermally messed up in here. That's what I'm going to have to do. If I can find that, that might cure this whole thing, because apparently it's thermally sensitive. So that's what I'm doing. Matter of fact, I'll put you in the tripod. Let's just get the heat gun out and just see if we can make this thing recreate. In for a penny, in for a pound, right? Alright, let me get everything set up here. Alright, y'all are good. Let me get my voltmeter leads out of the way. I'm not going to let this thing beat me. That's a yeehaw, or yeehua, yeehaw, I can't even pronounce it, 959D. Alright, let's just put a little heat right there. See? Just a little burst. Yep. Yeah, I'm going to have to pull this all out to where I can get to that board again and selectively heat each component, warm it up a little bit, cool it off, and see if I could find what's causing that instability. And that's all I know to do, so I'll bring you back in a minute. You know, I don't really know how to get everybody into this shot, you know, get everything into this shot. What we're looking at right now is it's basically one of the horizontal deflection plate outputs right here. And that tells you if it's sweeping or not. So right now it's on the 50 millisecond. Per division. I'm getting my heat gun set up. But you're going to run it about 230 degrees. A little bit of air, about. So, I don't know, where do you want to start? Let's start, there you go. Start over here and around the Q17, 18, 19, and 20 spot. That killed it right off the bat. Whoa, I wish I had some freeze spray. Alright, that was 18, that was one of these. That was Q20. Put a little heat on. That ain't it. Let's do 18. Q18. Again, Q18 right there. That's too damn simple. I need some freeze spray like bad. I keep forgetting to buy some. You can also use, oopsie. You can also, let me turn this air down, way down here. You can also use freeze spray. I'm sorry, my mind has just went dumb on me. You can also use canned air. I'm telling you, man, sometimes my mind just goes completely stupid. Some of the crap it says. I'm going to put an air barrier in here, kind of block thing. I'm just going to heat that one up right there. I heated that transistor up right there. Q18. Gave it a little blast of cool. I think I did. I don't know. I'm going to use my soldering iron to kind of get a little more precise here. Just warm it up on the bay. I just warmed it up just a little bit and it killed it. Thermally unstable transistor, but interesting. Problem you get into with this could be what they call a red herring area. I'm going to use a little bit of alcohol and dab it on top. Guess I'm still recording here. You can go down a rabbit hole with these things real quick. Now, like, okay, what'd I do? Let's try Q19. Maybe I was... See, Q19... It's working again. is I apply just a little bit of heat to it, put my finger back on it. See, it's just, I don't know, guys. Instead of y'all sitting here watching me make an idiot of myself or prove to the world how much more an idiot I really am, let me mess around with this, and when I come up with something conclusive that don't waste your time and bore you to death, I'll bring you back. Okay, I brought out the big guns. I've actually got this on my curve tracer. I've got Q18, which is one of the first transistors that was suspect. It's got a good trace on it. I mean, it's not bad. I'm going to heat it just a little bit. I mean, it's really, it went up a little bit, as you can see. But if I cool it back down, I mean, I don't think that's unusual. Really, I don't. I think for this older transistor, that's not unusual. So what I'm going to do, turn the curve tracer off, and I'm going to grab, I have another one of those transistors somewhere. If you'll give me just a minute, I'll find it. Here's one right here, fresh out of the package. So let me get it set up here. It'll take me but just a minute. Make sure I undo the old one. Make sure you hook these things up right in these curve tracers, because you can wipe them out. Base, collector, and emitter. Here we go. Fire in the hole. See, that's almost exact same as the other one. Got my heat gun. Full of heat on it. And actually, it doesn't seem to be as unstable as the other one. Honestly, just I mean, this thing's cold. It's probably about 45, 50 degrees. Bringing it back up to my body temp, about 98. I honestly don't think that's nothing wrong with that transistor. So I'm going to turn it off. I'm not going to put that transistor in there just yet. I don't think. Okay, here's the scenario. One of two things. Either it's a thermally sensitive transistor, which I have not found yet, or it's just the whole circuit is that damn picky. You get them getting a little bit warm, it throws all the bias off a little bit and all this kind of stuff, and it becomes unstable. It's already unstable to begin with. So let's find Q19. Find Q19 and we'll do the same thing. Alright, see, everything's upside down. There's Q18, Q19, there's 17, 18, 19. 19 what I'm looking for? Yep. Alright, there's Q19. Again, that's a 2SC371. Alright, let's hook it up. Flat side toward me, legs facing up, the base is on the left, collector is in the middle, and the emitter is on the right. Fire in the hole. That's not a bad trace. Let's see how it responds. What I'm looking for is one that changes drastically. That changes pretty good bit. It's not hot at all though. I mean, that's pretty warm on my hands. I mean, it reaches a plateau. I mean, yeah, you get extremely hot. I mean, without me getting my temperature probes out and everything and seeing exactly how hot I get the damn thing. And you got to get it pretty hot. I mean, that's hotter than it should normally get inside that. I mean, that's not unusual for a transistor. I mean, that thing's relatively hot. If it gets that hot, it's got something else going on. I just don't see these being a problem. The beta changes as it gets warm. So those transistors to me are acting normal. I mean, for 50-year-old transistors. Well, I guess just for grins and giggles, move you over here a little bit where I can see you a little bit better. Just for grins and giggles, apologize for the roughness. What we're going to do is we're going to check it again. I want to see what the beta does. I mean, we already know the beta is changing. Let's check it. Cold versus hot. Where are you guys? Alright, let me get set up. Ready? Spray the transistor. Test it. Alright, beta is 60. Warming up. Ah! Can't walk and chew gum at the same time. See, the beta changed to 96. I mean, really. That's where I'm at with this. Oh, I couldn't help notice the V forward on this was 666. What does that mean, I wonder? So, I think it's a red herring. I think the circuit is just so unstable that when that changes, it just affects the voltages on there, and that's what affects the thing working or not. So now I'm kind of wondering, do I want to pull these resistors and test all these resistors? I don't think that's I think we're just chasing a red herring. I don't know what to do with this thing. I'm really kind of back to square one, even though it is working on its own, but it's just not working properly. I guess I should have done this temperature test with this beta to see how these transistors reacted under. I don't know. I guess for grins and giggles, grins and wiggles, I'm going to test this new one that has not been installed yet. Let me widen you out just a little bit. We'll spray it. Turn it on. Let's see what it says. Beta 59 when it's cold. Now this is not very scientifically accurate because I don't know what the temperature was of the last one compared to the temperature that I'm putting on it this time. But I heated it up. Let's see what it says this time. Beta went up to 95. That's pretty much like the other transistor. So I guess the point I'm trying to make is the betas do change on transistors when they get hot versus cold. When it does, it affects voltages, it checks everything in the circuit. That's why on hi-fi amplifiers you have circuits in there, that bias circuits and everything that controls it, adjusts its own bias according to what temperature it is. In this thing though, it's so critical in there, that something is just so critical in there that anything at all will upset the equilibrium of this thing and make it work like it's doing right now. So that's the mission. We got to find out what's making it so damn touchy. It could be anything. It could be everything. A little bit of everything affecting these things. So I don't know. I'm going to put those transistors back in and I'll think about this. I'll probably get off this for the day. So anyway, I'll see you in the next segment. Alright, another day has passed. It's Wednesday morning here, state of Louisiana. Nice sunshiny day out there. Beautiful sky. Beautiful day the Lord has made. Had to get me a little cup of joe. Anyway, where am I at on this project? This BNK 1460. I had an interesting afternoon yesterday and I had to get off of it. My grandson came home, so I had to go tend to him. But sitting here mincing words right now. I'm trying to get my thoughts back together. But let's see. Let me recap just to get it in my head. I went through and we said we determined that it was a little bit of a temperature instability in this rig, and I used my heat gun on a very low setting, and this little group of transistors back here, that's the ones that was kind of being offensive. However, we put them on the curve tracer and heated it and cooled them, and you could see the beta change on them just by heat and cool. And that's kind of the par for these old transistors. They're not, you know, they're not super stable transistors. I think personally they were doing what they're supposed to be doing. One thing I did not check on the curve tracer, because it won't check it, is this FET right here. I just don't think that's a problem, because if I remember right, I think that's a 2SK30. I think. Yeah, 2SK30 right here, Q17. So I don't think that's a problem. So anyway, I said, okay, well, let's see. I'm going to check, and I said this yesterday, I want to check the sweep time variable, which is, you look on the front of here, the sweep time variable right here. This guy. I wanted to check all those components in there. But as you can see, a lot of stuff in there. So, but I got to looking at the schematic, and you'll see that there's the components in it right here. A bunch of capacitors on this side right here. This is a resistor bank. There's two resistors in here, and what it does is it selects this bank as you're going down from the half a second to 0.5 second all the way up to the 0.5 microsecond. If you're rotating that switch, basically what this does, this measures 4 meg, and then 1 meg, and then 0. Then it repeats 4 meg, 1 meg, 0, 4 meg, 1 meg, 0, so on and so forth, all the way down till it gets to here. So what I was able to do is this wire lead right here, 11 and 10. If you disconnect that, it completely oscillates this switch. Oh, and you got to take this resistor loose, R125. You take that resistor loose, cut it loose. This switch is completely oscillated now. You'll see that the connection here, it says there's a connection going through here. However, that connection is on the circuit board. If you'll note the black dotted lines right here, that indicates the circuit board. In other words, everything in this area here is the circuit board for the vertical and horizontal. Anyway, I removed 10, removed 11, and I get this bad boy over here. There it is right there. There's 11, and there's 10. If you can see them. Those are completely disconnected, completely isolated. And then R125, which is the 1 meg, is right here. It's cut loose. Alright. So now this thing is completely isolated. So what I was able to do, first off, is I went from here, this 1 meg, I went to right here, and from there I went to 11, and using my ohmmeter, I just started at the lowest range and worked my way up, and it did exactly what I said it did. It went from 4 meg, 1 meg, 0. Everything functioned, no problems there. Okay, well that said, the next thing is I checked these capacitors right here. This is on that feedback path right here, the Q14. S103D or E, I can't read it. Anyway, did the same thing. It goes in groups of 3. So the 0.22, 0.02, 0.002, 0.001, 100 picofarad, 10 picofarad, 100 picofarad, and whatever the heck that is. So I was able to go from ground to 17. Yeah, I forgot to tell you that I unhooked 17 as well with the Syncor. Put it in. I put it in all caps, all other caps mode. I set it for 20 volts, and then I would just do a value test. In other words, I started down here at the lowest range, which was 0.5 seconds, and went up. And every capacitor in here checked good. I checked it for leakage. No leakage at 20 volts. There's no more than 20 volts in here, so I checked it at 20 volts. Everything seemed to be good. So okay, so the next thing that I did, went up here, did the exact same thing here. I went from 11 to 10 with the Syncor resolver here, the capacitor tester. Same thing, I started at the 0.5 second and went all the way up, and all these capacitors checked good. No leakage between there. So now I know that that switch is not a problem. There's nothing wrong in that function. I mean that time-based switch right there. So we're good there. So the next thing, I got to looking around, and there's a resistor right here that comes off of our VR105A. And this is VR105A right here. But there's a resistor that come off of that. Let me get this out of the way. And it's on this leg right here. It's on the high side of that control right there. It went from there to here, I believe, to this red and white. Anyway, the schematic, let me find it again. R126. You see that? Can't tell what it is. I can't tell the value. It looks like it says something K, but let me turn the light on. Let me show you the resistor. Get my light on here and get all my stuff. Look at the color bands on that. I see either red, it could be red or orange, and then it looks like violet right here for the second band, and this looks like an orange for the third band. Whatever that is, looks like either it can't be a 37 ohm, so it's got to be a 27 in the first two. In other words, if that is a violet band right there, the second band right here, if that is a violet band, that's not a 3. That's got to be a 2 on the first digit. So, okay, so if that third band is orange, then that would make this a 27K. I don't know what this is. Whatever it is, measures 2400 ohms. I have no idea what it's supposed to be. Because on this wonderful schematic, I cannot see the value. Also, the manual does not state, does not even have a parts list. Right there. I have no clue what it's supposed to be. R126, let me get my pointer on there. Right there. No idea what that's supposed to be. It looks like the remnants of a K, but I can't be sure. I have no idea what this is. One of the crappiest schematics you'll ever find. I don't know what it's supposed to be. The color bands are faded. Like I say, I don't know what it's supposed to be. I'll come over to the manual. Let me look at them. Does not say anything about what that value is. Whether that's a problem or not, I don't know, but it's definitely something not quite right there. But I don't know for sure. Maybe I'm just being thoughtful. You know, there's no part list for this. Yeah, I can't even find it in the nomenclature here. So let's go find a different model. Let's see what a different model has to say. BNK 1460. Matter of fact, let's go over to Bama. All right, directories, B&K. Where are they at? Where's B&K? I didn't save the other version manuals because the guy sent me that manual. However, where's B&K at here? There it is. But I want to look at a different version and see what it says. Alright. There is some differences in this thing, of course. Where's my rotate tool? Rotate it one more time. Yeah, I guess that's what we get. So where are we at? There's Q10, which is what they're calling it. Variable. I can't read this. It won't let me rotate. Oh, that's reload. Big dummy. Where's my rotate function? Oh, crap. Alright, give me a minute here. I gotta find my download. Let's change the name of that. Alright, now let's open that up. Test equipment. Okay, 1460. There we go. Now we can manipulate it properly. There we go. Now it makes sense. So here's that feedback transistor right there. Here's those capacitors. So let's see. Here's the stability right here. That says 4.7K. R118 to ground. That's what that one's showing. Come back over here to this one. See, it is different. R126, the variable. Can't go on that. Here's D6 right here. This is similar. There's changes between those two. I'd have to sit down and study these schematics. It could be similar, the same, but it looks like it's not. This should be 12 volts. It goes to ground. That's 100 microfarad right here at 16 volts. That's probably the 12 volt bus. Yes, that's the 12 volt bus right here that goes to the collector of Q10. This emitter right here should come up, basically go all the way up here to Q5, which is what it does on the other one. So, going back over here, got a ground here, 126 on the high side. Let's go back over here. See, this one is on the low side. Let's chase it to the other way. Look, there's a 2.2K right there. R31, which goes over to VR10. So, is that what that is? Is that what that is supposed to be? Don't know. It's measuring 2.7K. That could be, and it's looking like now, this light that I'm looking at. Let me find you a dark spot here. That could be a 2700 ohm. If it is, then that's sure matching. Now the more I look at it, it looks like 27K. It looks just like that third band. Going from the right to the left, that third band sure looks orange to me. I don't know. I got to look at this a little more. That's what I'm facing this morning. This is where I stopped, and I got to think about that. Normally, if this is a 27K, they wouldn't drift down in value. They would usually drift up in value. I don't know. Let me think of this. I'll back in a little bit. Well, after viewing this thing and different lights and different colors and all this kind of stuff, looking at that band very carefully with a magnifier, 10 points, anybody recognizes what this is. But it's a 50mm lens out of a old Victor projector, 16mm projector. Had that for years. But anyway, after looking at this resistor, you could see very faintly, right here where my fingernail is, very, very, very faintly, if you quit biasing your mind that that's orange, you could see very faintly little traces of red in there. So this is a red, definitely a red band on the first band, on the first digit band. You can almost see it right there. So that is definitely a 2700 ohm resistor. That's what I'm going to call it. So there's nothing wrong with that resistor. So much as I thought it was kind of unlikely, but anyway, I'm going to put the resistors back in. I'm going to put them all back together, get the sweep circuit put back together, and then not sure what I'm going to do next, but that's where I'm at right now. Alright, well, this is like day 4 of getting back on this 1460 nightmare here. had got very excited that when I changed that bad transistor in there, the one that checked weird compared to the others, and it actually came up and worked on its own. It worked. Everything worked until it warmed up. I didn't realize it was a heat issue at the time, though. You know, then we went through all iterations. We pulled all the transistors out, you know, and done all that, and checked all the all the diodes and everything. I've done various permutations of work on this thing. I was able to come up with a way to check all of the components in the time-based switches to make sure that all the capacitors are good and all the resistors are good and no sneak paths or nothing like that. I've done various things as the other episode or the other segments, you know, has demonstrated. And then I finally realized that this is a thermal issue now. Like if I turn it on right now, it would probably work all bands. I guess all bands, all what am I saying? All the time-based selections, I guess you could say. So what I'm going to do is I'm going to hook my Textronics up to one of the ports here, just to look at this horizontal plates here. We'll get on this red one right here. All that is one of the horizontal plates for the CRT. That way I can see the sweep right here. Let's see. So anyway, I think it's ready to go. So let's just fire it up. Let's see what happens. We'll just do that one. That's kind of, you see it's kind of unstable right there, but it has no signal input to it. But the oscillator is kind of just free ranging. More than likely this R5, hang on. This R5 needs adjustment. See, it's already getting, there we go. Anyway, it will work like this, but VR5 right here, that control right there, is how you make this thing work. And you can turn it, you can turn the time-based selection to where it stops. Excuse me. And you can readjust VR5. And it will start working again and not work on some other areas. But as soon as you turn it on, it will function. But see, when I adjusted this yesterday, it had already been operating. That's why when I turned it on today, it didn't come right on again, because it was already on a different, it had a different characteristic. But you'll notice, look at that. That's odd. That's just like, looks more like data, a data pulse. No idea what it looks like on the CRT. So I don't know what to do with this thing. I hate to give up on this thing. I just really do. I put so much time and effort into this. It's not even funny. We're going to help it along here. We're going to use my hot air gun. And we're going to go down here to this group of transistors right here. seems to be really sensitive in that area. I don't know what's wrong with it. When we first started on this thing months ago, it worked. After I cleaned the board and everything, it actually worked and ran for a while. Then it died. We've changed a crap load of those 2SC 371s. I honestly don't know what's wrong with this thing. A lot of this stuff is direct coupled. So one stage affects another stage, and being this is a kind of a loop design, and that's the other thing about this, is it has a shifting personality. It doesn't always do the exact same thing twice in a row. Let's put the CRT in it. I went ahead and placed the CRT back in, kind of temporary. I still have the oscilloscope on here so we can see the trace. Firing it up. Let's see what happens. No idea. Well, you know where my trace is now. Do not have an indication here. What happened? There we go. That's what was up. I had the thing at 75 volts. Ah, that's when I was doing that. I still had it. I was looking at it, how it operated. It actually worked a lot better on reduced voltage. There we go. Now we got a trace. I mean, it works on 90% of them, a lot of time. It's working right now. I just don't know. It's like I almost want to take, I want to put a little heat on it. See, I just turned VR5 just a little bit. I get a trace here. And there is a spot at VR5. I don't think this one's going to work. That 0.5 seconds. I mean, it doesn't work on all ranges. There's going to be one or two in here that does not work. Like right there. Yeah, it's working. It's hard to see. All the glare in the shop. I don't know. I honestly do not know. Works, then it don't. See, there's one there that don't, excuse me, it doesn't work. That one doesn't work. That one works. You could almost not see it. I don't know how well you can see it on this. See how it does though? Reach the time base. Right there, and then you go over to this one. It's got, see the spikes? See it? That's what I'm running into with this. It's, I don't know. I don't really know where to go with this thing. All the transistors did check good. The beta changes as it, it gets warm. I mean, that's just kind of normal or common for a transistor. And all these old style transistors, Let's see if we can inspect that a little more. I don't know. I don't know what to do with this. I'm really want to get it working. I want to make it work. I don't like losing. However, the only other thing that I know to do, and I started on this the other day and I just didn't want to finish it up, was pull each resistor out. Every resistor in there one at a time and check it with an ohmmeter and see what is temperature coefficient. In other words, how does it respond under temperature? It could be a resistor changing value. But I'm just, okay, corrosion got on this board. Okay, it was subjected to water, Lord knows what else, where this thing came from. So it did have a ton of rat shit on it, rat pee, so that's acidic. That's got into components, as you could tell by some of the transistor leads that were corroded off. So am I dealing with still bad transistors? Am I dealing with resistors that are somehow corrupted? I can't think of the better word. Or contaminated internally? Do I have capacitors somewhere that I hadn't noticed? All it is in there other than electrolytics is just ceramics. So I don't know what to do with this thing anymore. Is it just because maybe I don't have it adjusted right? There is no manual on a full alignment on this thing that I could find. I hate to give up on it. I've even considered taking those transistors and finding a little bit more modern replacement for them. I thought about maybe You know, it's 2N2201s or something like that to replace those 371s. I don't know. I don't know what to do with this. This Thursday here, and when did I start on this? Sunday or Monday? I've been on it 4 days. I don't know what to do with it. Any thoughts and suggestions? I would be open for any help on this right here. I just really hate to give up on it, but I'm really just tired of messing with it. I'm probably going to turn it off, put it back together, and get back on it another day. My mind is... I've checked everything I know to check. And I bought bags of these 2SC371s, if you remember. And they all check good. I mean, they check... Like, I pulled some old ones out of this scope that were good from different areas, and compared the new ones to the old ones, and they all seem to be about the same. What I don't know is if all these transistors match to a certain kind, you know, to a certain beta range when they put them in here. I don't know. It could be something of that nature. It could be these components are not quite matched. There could be some differences in them, and they don't play well together. I don't know. I don't know what to do with it anymore. I hate to give up on it. I'll spend more time and money than this thing will ever be worth. I don't know. Thoughts and suggestions. I would be appreciative. I don't want to get rid of this thing. I'll probably give it one more go here sometime next year. But it's a pain in the butt. So anyway, I appreciate you guys watching. Thanks for tagging along here, and y'all have a great new year, and we'll see y'all on the other side. Take care. God bless. All right, just for I'm sitting here producing a 2.5 hour long video on this stupid thing, and what I want to do, I had a thought while I was drinking my third or fourth cup of coffee. My face is numb. But what I want to do is take a 2N3903 NPN silicon general purpose transistor, little dude right here. First I want to put this dude, I want to identify the leads on it. I think it's EBC on these. I want to identify the leads on it, get a beta reading of it on my tester, and then I want to put it on the curve tracer and inject it to a little bit of heat. I want to see what the temperature rise does. I want to see what this does in relation, how this trace looks like compared to the 2SC371s. And what I'm thinking about doing, if they're fairly close, let me move this out of the way. If they're fairly close, I'm thinking about swapping all of those transistors to these, because I got a pile of these. Don't know where I got them from. So let me put you down here. So let me spread these legs out just a little bit. All right. There's 1, 2, 3. BJT, NPN, beta of 143. A little bit higher, almost almost double. But in that oscillator circuit, that could be what we're looking for. Alright, so now, oh, I didn't get the, let's see, one. I gotta retest it. I forgot to see what the pinouts was on this stupid thing. My bad. Try it again. Let's see here. So that's collector, base, emitter. Actually, it's emitter, base, collector. Okay, I got it. Now, let's hook it up to the curve tracer. Oh, we got to hook up. We got to set it up. Let me set it up. All right, I've got the 2N3903 in the curve tracer here. Got it set up, and what I want to do is I just want to see how it responds to temperature changes. All right, here we go. 1, 2, 3. See, that's a lot more stable. Yeah, that didn't drift a whole lot as compared to those other transistors. That's interesting. Now let's compare that trace to the 2SC371. So I got to dig one of them out. Give me just a second. Bear with me. Bear with me. B, C, E. Get this right. B. C. Hope I don't blow this up. Here we go. Fire in the hole. See? Now, subject it to a little heat. Look how fast that one rises. Whoa, look at there. Whoa. I'm going to change every one of them damn transistors. Might take me a few minutes. I'm going to change every damn one of them. See what happens. All I can do is blow up. Well, this is a Hail Mary moment right here. I went in here and changed Q11, Q12, Q13, and Q14, all with more modern transistors. 2N3903, I believe. And let me drop my stuff. General purpose transistors. They had a lot more beta, about 143 I think it was, but they would seem to be a lot more stable. So, unless I put something in backwards, let's try it. All I can do is blow up. Got the CRT in, it's plainly obvious. Look at there, I have a trace. Had a trace. Well, that's, at least it worked for a microsecond. Play with Q. don't have many of these left. Well, it worked for mere moments. Still ain't really figured out what that variable capacitor's for. Yeah, it don't do diddly crap now, does it? It don't do anything anymore. It did there for a minute. Alright, that's it. I'm calling it. I'll do an auto. I'm gonna pull those transistors back in, out, put those originals back in. And I'll check those I just put in there to see if there's any of them damaged. That's it. End of the line. I'm tired of working on it. Tired of wasting my time on it. And I'm going to pull my new parts that I put in there out, and I'm going to put it as a junk pile. That's it. Thank y'all. Bye.